Okay. Thanks everyone for coming. We are starting our presentation. This is the AT&T Integrated Cloud transition from virtualized to containerized control plane CICD. Presenting will be Rick Batra from AT&T, my colleague Rick Batra from AT&T, Stacy Fletcher from Accenture, and I'm Milind Belhay from Ericsson. The agenda for the presentation today is we'll go over the we'll start off with the virtualized control plane CICD introduction. There will be a brief overview of network cloud architecture and on to the network cloud Seaworthy Pipeline, which is the containerized control plane CICD pipeline. We'll have some time for Q&A at the end. Okay, start off with virtualized control plane CICD. Again, this is our basic Jenkins pipeline. I've highlighted the box towards the left. That's the part we'll be focusing on mainly on this slide. This is the CI part. This whole pipeline is what our code goes through. Our every merge to our CI infrastructure, our code base goes through. All these are each section in that pipeline is basically think of it as a gate. For every for every push to get it, we will execute the usual syntax checks, unit tests, and basically the pepper checks. We also enforce. We have strict enforcement of bandit scans for every repository that we have. So bandit, unless it passes our strict bandit checks, the code doesn't get through the gate. The next step is basically the packaging. We deployed on Ubuntu, so we have Debian packages. Those packages we need to make sure that the packages can be deployed. So we have a quick package check, a Dockerized package check gate in there as well. We also run a very small integration test, which basically is deploy the OpenStack infrastructure with the new change and perform some quick temp and smoke tests on it. That is also a good gate to have. Apart from that, we have nightly scans for Sonar and Fortify for providing static and dynamic code analysis and more security vulnerability scanning. On the right of the, once the artifact is published, we are publishing into our internal repository. It could be Artifactory or any other Debian hosting repository. On the right of it is our kind of a deployment pipeline. I'll go through that in our next slide, real quick. Okay. So our deployment framework, we are calling it FullCD, which is a fully automated and kind of a data-driven deployment framework. We have, in our process, we realized that we need to be deploying in our CI framework whatever we are whatever tools and configs we are using to deploy in our production. That is really important, right? So FullCD helps us achieve that. FullCD is how we deploy our production environments, and we are using the exact same framework to deploy our CI environments as well. Right? It's basically designed to eliminate the human factor from deployment. Basically mechanized deployments of basically greenfield, brownfield scenarios, as well as we also have update or patching scenario in there. It performs pre-checks and post-checks on the environments. We have ability to run Tempest and other tests. So that's basically what we have for our CD pipeline right now. Okay. Next, jumping on to containerized CICD, right? So what changes? Again, this is a very high level picture. There are a lot of steps that are that we'll go through. Stacy will go through in her presentation. But think of it. At the top of the picture you see is basically our current pipeline where our artifacts are Debian packages, and we basically run them through FullCD and Once that stage is passed, we consider those artifacts as stable, and we're able to deploy them or production ready, you may say. In CICD, it is the same, very similar exact initial steps. The step, you can see steps 1 and 2 are exactly the same. We run the exact kind of strict checks on the code. The deployable artifact is basically an image, a Docker image in this case, right? Which we are using Loki to build Docker images. Again, Loki, what is Loki? I'll explain that in the upcoming slides. Once the image is published, we need to make sure it is a sane image. So that's where the Seaworthy Pipeline comes in. Again, there will be slides in the presentation later to explain what that is. We jump on to a little bit of Loki. So what exactly is Loki? So Loki is OpenStack project. It is designed to quickly build lightweight OCI compatible images of OpenStack services. It is very easy to, integrate into any CI framework. I'll show you a short demo of how easy it is to create an image using Loki. Loki uses bin-deb profiles to specify which packages get installed. I have shown a small example here of Keystone image. So when you're building Keystone image, and this example will be more clear in the next slide, but in this image, in this example, I'm building a Keystone image. While building a Keystone image, I'll pass a build arg of profiles, which is Apache LDAP. Loki will refer to the bin-deb.txt file, which I've provided the link there. Again, everything is in GitHub. And you will see what that LDAP profile maps to. So in this case, we are using Debian packaging, so it will take that first line here, LDAP maps to liblldap 242. So that's the package it will pull in while it is creating the image, and it will be part of the image. This is the basic full command to build a Loki image. Maybe looks daunting at first glance, but I think it's very easy to understand. It's the usual Docker build command with you pass it the Loki Git repo. The next arguments are the proxies. Again, which we are behind the enterprise firewall, you will need those. Then we have the project repo is the project you basically want to build and get included in the image. The project ref is the branch or the git ref. So if you are putting this in a CICD environment, that would be your ref spec, your Gerrit ref spec, for example, right? The next one you can see it's from is Ubuntu Xenial. That is the base image that is required for building the container. In this case, we are using just the upstream Ubuntu Xenial, but it can be any of your custom Ubuntu image. Right. The next one is a project. This again is using Keystone profiles is what I just explained. Those are the Apache and LDAP are the profiles for Keystone. Pip packages are any additional packages that you would like to install in the image. Wheels is the location of the wheels tarball or the wheels image, which basically either you can provide a wheels image that you create using the same Docker build command, you create a image from the requirements repository, or you can if you set it to null, I think it will create an image for you from upstream. And the last one is a tag, basically. So the tag is I'm giving it Keystone tag. I'll show you a quick demo if I can bring it up. Not this one. There you go. Show you a quick demo of how this command runs, basically, right? So again, you will see how it is really very easy to build containers from. So it's the same command I have executed, and I'm going to fast forward this, but basically it will start getting all the dependencies and the additional packages that you have mentioned in the command. It takes maybe 2 to 3 minutes depending on your network latency to build the actual image. Once the image is built, you will in the next few slides we'll see what exactly is how exactly we make it consider it as a stable image. I don't want you to put you guys through this, but I'll fast forward it real quick. So yeah, so basically you can see the image is created and tagged, and you can push it to your repository anywhere. And so that's basically it for the Loki part of it. The next step is next part is for Rick, and he's going to go through the network cloud architecture overview.
Thank you, Mullins. Can you guys hear me okay?
Yeah.
Cool. So my name is Rick Bartra. I'm an engineer at AT&T, and I'm going to be giving an overview of our network cloud architecture. This will provide good context for explaining the pipeline later on. So as you can see on the screen, we have a nice depiction of our architecture. And so today I'm going to be talking about and giving an overview of some AT&T developed components. And after I go over those, I'll kind of give a little explanation of how they all work together. So on the screen, the components that are highlighted in green, those are other open source projects and components that Airship integrates with to deploy the undercloud. So the components in blue, as I mentioned, they were developed by AT&T, and they belong to the Airship project now that was recently donated and adopted by the OpenStack Foundation. So what exactly is Airship? So Airship is a broad integration of several components that enables an automated, resilient, Kubernetes-based infrastructure for hosting Helm-deployed containerized workloads. So the first component I'm going to talk about is called Deckhand. And Deckhand is a document-based configuration storage system, a service built with validation and auditability in mind. Some of the core responsibilities of Deckhand include layering. Layering basically ensures there's no duplication in configuration. Substitution, which enables you to separate your secret data from other configuration data. Revision history, which provides a means of auditability. And validation. Validation allows other services to implement and register different validations in Deckhand and report errors as appropriate. Next up is Diving Bell, and Diving Bell is a lightweight solution for bare metal configuration management and bare metal package management orchestration. So Diving Bell was actually developed for primarily 3 different reasons. Number 1, it's supposed to address any gaps that exist in day 1 bare metal configuration, node configuration. 2, it's supposed to provide a solution for day 2 configuration management and to carry that forward. And 3, basically we want to have a day 2 solution for system level host patching. Okay. So next up is Promenade, and Promenade is simply a tool for bootstrapping a resilient self-hosted Kubernetes cluster and managing its lifecycle. Promenade actually works closely with another component called DryDock, which I'll be explaining later on. So just keep that in mind. Next is Shipyard. Shipyard is the directed acyclic graph controller for Kubernetes and OpenStack control plane lifecycle management, and it actually provides the entry point to the following aspects of the control plane. Designs and secrets. So designs could be anything like complex network designs, configuration of bare metal nodes, Armada manifests, Helm charts, etc. And secrets are essentially just like certificates or passwords. And actions, this kind of refers to workflows within the control plane that are managed by Shipyard and monitored by Shipyard. And just as a side note, Shipyard uses Apache Airflow. Next is DryDock, and DryDock is a provisioning orchestrator for bare metal nodes that translates a YAML-based declarative site topology into a physical undercloud that can be used to build an enterprise Kubernetes cluster. So what's cool about DryDock is that it uses plugins that leverages existing provisioning systems, so you can use a provisioning system that best meets the needs of your environment. We actually use Ubuntu MAS as our provisioning system, and we're looking to add Ironic in the future. Next is Armada, and Armada is a tool to manage multiple Helm charts with dependencies, by centralizing all configurations into a single Armada YAML. It also provides lifecycle hooks for all Helm releases. So some core responsibilities of Armada include multiple chart deployments and upgrades via Armada manifest, managing multiple chart dependencies using chart groups, extending base Helm functionality, and it also supports keystone-based authorization and authentication. So I kind of gave a high-level overview of several of these components, and now I kind of want to tie it together for everyone. So I'm just going to give a quick example of how that all works. So initial site or region data is passed into Shipyard from either a human operator or something like Jenkins. Shipyard will then interact with Deckhand to pass that data in YAML format for storage and validation in Deckhand. Shipyard will take the post-processed data from Deckhand and interact with DryDock. And from there, DryDock will interact with Promenade, and it will deploy and provision bare metal nodes using Ubuntu MAS. And at this point, by the end of that flow, a resilient Kubernetes cluster should be up. Once that's validated to be working correctly, Shipyard will then interact with Armada to deploy OpenStack using OpenStack Helm. And lastly, a workflow will kick off to do health sanity checks on the cluster. So I just want to hammer in a couple more points. So all these components, they now belong under the Airship project. Most of these are actually Python-based projects. And so they follow the same standards that exist in other OpenStack projects in terms of gating. So we do PEP8, Flake8 checks, unit test checking, functional test execution, and whatnot. Additionally, we also have a gate that deploys a 5 VM cluster with the proposed patch set, and this is very high level, but basically if that passes that, the next step is a Docker image is created and published to Artifactory. So now I'm going to turn it to Stacy, who's going to give an overview of the pipeline.
Hello, everyone. So what is Seaworthy? Seaworthy, this is a Jenkins pipeline, and it can be found in our CICD, AT&T ComDev, GitHub repository. It's defined as a Jenkins file. It is a pipeline that's going to integrate Airship and OpenStack Helm. And when we get to this pipeline, we can assume that any of the images or Helm charts that have passed their initial gating process that Rick was just talking about. And now we want to put it through a more extensive integration test. The demo I will be showing today is going to be a greenfield deployment, and we are going to deploy to bare metal servers, ending with a containerized OpenStack instance. Okay, so this is a view of everything that is involved with our Seaworthy pipeline. From the left to the right, we have our documents in the top left. These documents declare our intentions for the site we are about to deploy, and all of these documents are version controlled in Git. Next is the host server, and that has our containerized Jenkins and Artifactory instances. And then the middle host is a virtual machine that is dynamically provisioned by Jenkins. And this is where we start the Genesis process. At the end of Genesis, Airship is deployed and ready to provision the rest of our bare metal nodes. And then finally, the right side, we have our 4 bare metal servers. So here, each patch set that goes into our document repository on our top left, we will do validation checks. And what this does, it goes through Pegleg, Promenade, and Deckhand, and it is essentially doing everything that we would do on a real deployment, but we don't want it to go to a production site and to go through these checks for the first time. Okay. Next, we are going to show a demo.
Okay.
Okay. What? Is it ready?
Yeah. Yeah.
Okay, so we begin with the servers being wiped to remove the previous deployment, and even the Genesis node is re-provisioned at this time. We don't want anything left over from the prior deployment. After that is done, this is the first step. We are going to move on to Pegleg collection, and that's again, it's taking those documents from the Git repository. For this case, the manifests are in Airship treasure map, so everyone can take a look on the documents that we're actually deploying. And then Give a second. I'm going to actually show treasure map and after this. Well, if it all passes the next stage of the pipeline, oh, there's treasure map, sorry. I'm a little off. If all passes the next stage of the pipeline is the generation of the Genesis script by Promenade. It's using the documents that are defined in our treasure map repository. We then take this script and we are going to publish it out to Artifactory. Next, we are going to publish site configurations, and this is made up of deployment YAML. So Pegleg concatenated all those documents. We're going to push those out to Artifactory, and then Promenade also generated all these certificates that we need for this deployment to work. And that's also going to be published out into Artifactory to be used. As soon as everything is published, we're going to start installing Kubernetes on the Genesis node as well as Ceph and then Airship, and then we call this process Genesis. And I'm going to bring up a console screen in the top right to show that it's been started. Almost there. And here's our console. I'm using kubectl command to show our pods. All namespaces are being shown. Here you can see that Kubernetes is being installed. Once Airship is up and running, we are ready to load the documents into Deckhand, and Deckhand is going to do some more schema validation, layering, and substitution that we talked about earlier. Off and on, you're going to see me hit the pause button, and this is because this deployment does take longer than the 7 minutes that we have to demo it. It's going through, and this is doing some dry dock validation at the end of it. What Deckhand is talking to dry dock, it's saying it's successfully validating everything. And now we are at the point where we're going to start deploying our site. This is done using Shipyard's API and telling it what we want to deploy. The pipeline does look linear in Jenkins, but behind the scenes, Airship is actually doing things in parallel. You can also see that I am pausing off and on. Sorry, I said that already. The pipeline does take longer. So let's just give it a second. We're going to go through the stages. This is showing the steps of Shipyard that it's taking, and you can see there are multiple steps. You can see there are pre-flight checks. We have verify site, prepare nodes, and many more. So Shipyard is going through those steps with each of those servers and doing what it needs to do. Right now, we are waiting for the very end to say Armada get releases to be successful. And then we are going to go, I'm going to open up the terminal again, and I'm going to show that Kubernetes, Ceph, and Airflow are all now ready. And there's Ceph and Kubernetes. Just throwing. And right now we're seeing Git releases is success. Then And again, we're going back to our terminal. Going to hit pause while we're waiting for everything to come up. And here is Ceph, kube system, and then UCP is actually airflow. I'm doing a -O wide, and it's showing on the right side what node is being deployed on, and this is all Genesis node. So we're coming back, and the deployment has continued. Armada has now started deploying OpenStack Helm. I've changed the command to watch on only the OpenStack namespace. So you can see here that MariaDB, Ingress, and Ceph are now being deployed. Again, on the right, very far hand right side, you can see that it's being deployed on controller 1 and controller 2. So we are not using the Genesis node at this point. And just give it a couple of seconds. There's a couple of workers that we are now deploying to. So we have our compute nodes. So worker 01 and 02, which makes up our 4 bare metal servers. And the command I changed in a second, I'm going to change it. I'm going to highlight the section that I updated. This is using Kubernetes 1.10. And the command to show only the running pods has changed. So, and midway through, I found this out. So I'm going to highlight it at the top, and it's going to see, you can see now everything's in running status. So we're good. We've deployed our fully containerized OpenStack Helm instance using Airship. Sorry about that. Okay.
Okay. Okay. Thank you, Stacy. We're done with that. Okay. And I mean, to end with it, I mean, we're just putting out some of our CI/CD infrastructure metrics here. We are in AT&T. We are supporting 11 server types, 6 storage types. We have 3 or 4 parallel releases going at every given time. We have more than 182. This was pulled like a couple of months ago. So we have more than 200 internal code repositories that our CI system is supporting, more than 7,500 automation hours, and it's more than 4,000 code commits in the past 12 months. And this is not counting some of it is not counting the upstream commits. So want to point you to certain websites, again, ATT ComDev, GitHub ATT ComDev, Loki, airshipit.org. Do visit that. That's a good starting point for everything that we are doing. Also, don't forget to attend the upcoming presentation regarding OpenStack and Kubernetes. How do you pronounce that? Smorgasbord. That is tomorrow at 9 a.m. 9:40.
Yep. Same room.
Same room. Yep. That brings us to the end of our presentation. Thank you everyone for attending. We'll take some questions if you have any. Any questions?
Hi, I have a question. One of your services that is based on for bare metal service, is it based on Ironic, or you're using like your own implementation for bare metal management?
It's using MAS, Metal as a Service.
Yeah.
Yeah.
MAS from Canonical.
Yes.
Oh, got it. Thank you.
Yep.
Any more questions? Okay. If
Cola? No, we use Loki. So the section that you said on the Loki, we use Loki build process. It's a little more lightweight and a little bit faster than Cola. If we have Pete in the back, he's one of the creators of the Loki build process. So it does support both, yes. Yeah.
I will say from a developer's perspective, I've deployed OSH and all-in-one, and using Loki images, at least for me, was much easier than using Cola. It was a lot more straightforward, and as Stacey said, very much more lightweight and a single image for the service instead of a bunch of different images for Cola.
Okay, any more questions?
Any other questions?
Comments? No?
Thanks.
Okay.
Thank you.
Thanks everyone for attending.
Thanks.
Appreciate it.